In this session, we shall start studying about refraction of light through lenses. Already you have studied about the concept of refraction of light, is it not, in your lower classes? So this refraction of light takes place through a glass prism also. So a glass prism also refracts the light, and even a lens also refracts the light. Now coming to lens, let us know what is the definition of a lens. A lens is a piece of transparent material. A piece of transparent material which has at least one refracting surface. Okay. So what is a lens? A lens is a piece of transparent material. Transparent material means light can pass through that, and it has at least one refracting surface. Now the lenses we use, usually they have two refracting surfaces. Two refracting surfaces. Some lenses have only one refracting surface also. Like there are various types of lenses. You have plano concave lens. Okay. So here one surface is plane and the other surface is refracting. This is the refracting surface. One surface will be plane, one surface will be curved. Then we have plano convex. Here also one surface will be plane, one surface will be curved. In this only one surface will be refracted. Then we have double convex and also double concave lens. Okay. So this double convex and double concave lens is also called biconvex and biconcave lenses. Usually in our daily life we are using double convex and double concave lens only. Of course, in some of the scientific instruments we use plano concave and also plano convex lenses. So in this unit, let us confine our study only to double convex and double concave lens, or simply we can write it as convex and concave lens. Okay. So you have to remember, mainly there are two types of lenses which we are studying in this unit. One is convex and the other is concave lens. Now this any lens if you take, it can be considered as an arrangement of prisms. Already you have learnt about refraction of light through a prism. Whenever a ray of light enters a prism, then what happens? The prism will refract the light rays, and the emergent ray will always move towards the base of the prism. Is it not? So keeping this in mind, let us now see how any lens, whether a convex lens or a concave lens, can be considered as an arrangement of lenses. Okay. I will draw the ray diagram for you. Taking two prisms, arranging two prisms. Now this is one prism I will take, and this is the other prism. Okay. Now this is prism 1 and prism 2. You can see that prism 1 is upright and prism 2 is inverted. So two prisms are arranged in such a manner. Let us consider two light rays. So one light ray entering prism 1. Okay. One light ray entering prism 1 and another light ray entering prism 2. So let us consider A and B are the two rays entering the two prisms 1 and 2. Now according to refraction of light through a prism, what we have learnt? The prism will refract the light ray and the emergent ray will always move towards the base of the prism. Is it not? So this will be the emergent ray for prism 1. Now if you take the prism 2, then this prism also will refract the light rays, and the emergent ray again will move towards the base of the prism. So these are the bases of the prisms. Now, if you consider the arrangement of two prisms in this manner, then you can observe that the light rays, after getting refracted through the prism, they are meeting at a point. Is it not? Means they are converging at a point. Now, in order to converge the light rays at a point, how you have to arrange the prisms? The prism should be arranged in this manner, one upright and one inverted. Okay. Now, out of this arrangement, I can imagine a type of lens. See here. This will be the type of lens. If you have a lens like this, then what this lens will do? It will converge the light rays. Is it not? Converge means what? All the light rays coming from different directions will meet at a point. So this type of arrangement will give us convergence of rays. And what type of lens can be imagined out of this means you can imagine a convex lens. You can imagine a convex lens. So a convex lens diagrammatically, two-dimensionally I can represent like this. Two-dimensionally I can represent a convex lens like this. So usually a lens will be spherical in shape, but it will have a curved surface. Either you take a convex lens or a concave lens. So here, what action we are observing here? We are observing converging action. We are observing converging action. So this type of lens can be used as a converging lens. Understood? So which type of lens can be used as a converging lens? A convex lens can be used as a converging lens. Now one more arrangement of prisms I will draw. This is the first prism, okay, and this is the second prism. Now again let us consider two light rays incident on the prism. Now how the light ray will bend? It will move towards the base of the prism. Here also it will move towards the base of the prism. Now if you produce this light ray, emergent ray backwards. So try to produce the emergent ray backwards. Then you will observe that the emergent ray is coming from a point. Is it not? So from this point, these two rays appear to diverge. So this type of arrangement of prisms will give us diverging action, and what type of lens we can imagine out of this arrangement means we can imagine a concave lens. You can imagine a concave lens. And how you should draw the two-dimensional representation of a concave lens? Like this you have to draw. This is a concave lens. And here you can observe that when I arrange these two prisms in this manner, then it will diverge the light rays. So a concave lens can be used as a diverging lens. Concave lens can be used as a diverging lens. Understood? So these are the concerned ray diagrams for arrangement of prisms in a certain manner to get converging and diverging actions. Okay, please note the diagrams. Next, how to distinguish a concave lens and a convex lens. So if you are given a convex lens and a concave lens, then you can easily distinguish between the two types of lenses by feeling it in your hands. Now a convex lens, I will represent like this. A convex lens will be bulged at the center, and tapering at the edges. tapering, or you can just tell it as thin at the edges. So such type of lens will be a convex lens. Okay, and if you just pour a drop of water on a convex lens, then the drop of water will move towards the circumference of the lens because the lens is bulged at the center. On the other hand, if you take a concave lens will be thin at the center and thick at the edges or bulged at the edges. So if you pour a drop of water on a concave lens, then it will remain at the center of the lens only. Whereas if you pour a drop of water on a convex lens, it will move to the circumference of the lens. Understood? This is how you have to distinguish between the two types of lenses. Now, let us come to some of the general terms related to lenses. General terms related to lenses. Now, what is the first term you have to remember? The first term you have to remember is center of curvature of the lens. So while you are going through this video, I recommend you to refer the textbook for the necessary ray diagrams for all the terms related to lenses. Now, what is center of curvature? Now see here, any type of lens you take, whether either convex or concave lens, it consists of two refracting surfaces, two curved surfaces are there. Is it not? These two curved surfaces can be imagined as a part of a sphere. So you should imagine a sphere. You should imagine a sphere. Okay. So two spheres if you imagine. Two spheres if you imagine in this manner, then see, if you cut only this much part of the sphere, then how you will get? This is one curved surface, this is another curved surface. So you can just tell it as a concave lens. Is it not? On the other hand, if you imagine the spheres in this manner, see here, if you imagine the spheres in this manner, then these two curved surfaces if you consider. So this curved surface is a part of this imaginary sphere and the other curved surface is a part of the other imaginary sphere. Now, using these two spheres and curved surfaces, what type of lens you can imagine? You can imagine a convex lens. So, center of curvature is nothing but the center of the imaginary sphere of which the curved surface is a part. So, how you can define center of curvature? The center of the imaginary sphere of which the curved surfaces are the part. So if you consider two spheres in this manner, then you can just imagine a convex lens out of the two curved surfaces. And if you imagine the spheres in this manner, what type of lens you can imagine? You can imagine a concave lens. And these two spheres will have centers. Those centers are called centers of curvature. So you can just name them as C1 and C2. Is it not? So these centers of curvature can be named as C1 and C2. So remember, center of curvature is the center of the imagined sphere. We are imagining a sphere out of the curved surface. That center is called the center of curvature. Okay. Note down this definition also. So the next term related to lenses we shall know. So what is the first term, children? It is center of curvature. As I have told you, center of curvature is the center of the imagined sphere of which the curved surface or refracting surface is a path. Now, just see here, the next second term is the radius of curvature. These spheres, imagined spheres, will have certain radius also. That radius of the imagined sphere is called the radius of curvature of the lens. Understood? So, diagrammatically I have shown here, these are the two spheres and this is one of the radius of curvature. So, if you take any lens, either a convex lens or a concave lens, it will have two radii of curvature. Is it not? Next term is principal axis. Now, principal axis is the imaginary line joining the two centers of curvature. So, if you draw an imaginary line passing through the two centers of curvature, then that line is called the principal axis of the lens. So, you can draw a principal axis both for a convex lens and a concave lens also. The next term you have to remember is optic center. So, what is optic center? It is the geometric center of the lens. So, if you take a convex lens, the geometric center of the lens will be optic center, and optic center is denoted by the letter O. Okay, it is denoted by the letter O. And remember that any ray which is passing through the optic center will go undeviated. Understood? Means it will not undergo any refraction. Even for a concave lens also I have shown here optic center. Is it not? So, the ray goes undeviated when it is incident on the optic center of the lens. Now, till now 4 terms we have learned. One is center of curvature, the second one is radius of curvature, the third one is principal axis of the lens, and the fourth one is the optic center of the lens. In the next video, we shall learn some more terms regarding the lenses, that is principal focus, focal plane and focal length of the lens. Thank you children.